Singapore Mathematical Olympiad SMO 2019 open section round 2 problem 3. Again, we want to learn how to solve a problem, the ways, the techniques that help us for solving a difficult problem, not only the solution of the problem. This problem is from combinatorics topic. Says a robot is placed at a point P on the x-axis but different from 0, 0 and 1, 0 and can move only along the axis either to the left or to the right. Two players play the following game. Player A gives the distance and B gives the direction, and the robot will move the indicated distance along the indicated direction. Player A aims to move the robot to either 0, 0 or 1, 0. Player B's aim is to stop A from achieving his aim. For which P can A win? We consider three different parts of x-axis. We write each point in these formats. We doesn't write the array coordinate of the points because all of them are 0. So we want to reach 0 or 1 in this axis. If we divide into this axis into intervals I1, I2, and I3, then if the point is on I1, then player B gives direction toward left, and the robot goes left and won't reach to 0 and 1, and in this case player A can't win. By the same way we can prove I3, so we must consider only I2. We consider this case by a small example of steps for reaching 0 or 1. That's the critical point of the solution. For example, which point can reach to 0 or 1 by one step? It's the midpoint. If the point is 1 over 2 and the distance is 1 over 2, then either player B choose left or right, the robot will reach to 0 or 1 by one step. In two steps, if we consider the midpoint of this interval and this interval, the red points, then the player B can reach the player A gives distance 1 over 4, and if it was necessary in the next step 1 over 2, then the robot will achieve to 0 or 1 with at most 2 steps. You can consider all the cases. For example, to the left, if the player B at first choose left, then by one step we reach from this point to 0, and otherwise we reach to this point, and after that to 0 or 1. You can consider all the cases and prove it. Now we guess that these midpoints are the points that cause we reach to 0 or 1, and player A can win. We write these points in these formats, and also we write 0 and 1. The robot can't be in there, but if we reach 0 or 1, we can win. And we want to say that A can win if P belongs to S. Otherwise, A can't win. In the case, we must prove two cases. At first, K1, if P belongs to S, we demonstrate by using induction. N is 1. If N is 1, it is obvious, and we can assume for N 1 until K, and prove for N equals K plus 1. Now P is X over 2 to the K plus 1. If the numerator and denominator have common factor, we can cancel it and the power of the denominator will decrease, and by the use of induction we can prove it. So we must consider the case X, the GCD of X and 2 to the K plus 1 is 1, and if player A gives distance 1 over 2 to the K plus 1, then we reach X plus or minus 1 over 2 to the K plus 1. We name it P1. By the use of the star, we can assume X is odd. And now we write P1 in this format, and the power of denominator decrease, and by the use of induction, player A can win. You can prove that this fraction satisfies the condition of S set. We write the proof of it here. And now we wanna prove case 2. If P does not belong to S, then we claim that player B can play in a way that robots never reach to a point belongs to S. We prove it by contradiction. And we want to say that if a robot reach to a point belongs to S, we assume Q is the first point in S that it achieved. And in this step, B had not any alternative. Either he choose left or right, the robot would reach to S points. Now we consider the previous point that the robot come to Q from there, and we name it Q1. Without loss of generality, we assume Q is less than Q1. Now we write them on the x-axis. Q2 and Q1 distance, the distance of Q1 and Q2 is D, and Q and Q1 also is D. We said player B had not any alternative for going left or right. Either he choose left or right, the robot would achieve to S points. So Q and Q2 belongs to S, and if we write Q1 coordinate, it's the arithmetic mean of Q and Q2, and we write it and we simplify it by using of common denominator. Without loss of generality, we can assume K1 is less than or equal to K2. We write Q1 in this format, and we can prove this format satisfies the S set condition. At first, we must prove numerator is less than or equal to denominator. Q and Q2 belongs to S, so these two fractions are between 0 and 1. The sum of them is between 0 and 2. By dividing by 2, this fraction is between 0 and 1. So we proved this condition. Also, you can prove the other conditions, and then we can prove Q1 belongs to S. In the sense that we said Q is the first point that the robot reached and Q belongs to S, now we proved the previous point also belongs to S. And now we reach contradiction, so we proved this case.